So good afternoon everybody, myself Acharya Vishvendra. Let's discuss a numerical based on elasticity. So for a certain material, bulk modulus is given here. Then we need to find its, the first question is compressibility. Then volume in air is this much and mass is this. Then find its density in air. Then find volume inside at a certain depth. Then we need to find volumetric strain, then percentage volumetric strain, then a fractional change in volume, then a fractional change in density, percentage change in density, and dimensional formula of compressibility. So the very first question is about compressibility. So compressibility is 1 upon bulk modulus. So the very simple explanation is compressibility is 1 by bulk modulus. So if we draw the graph will be a straight rectangular hyperbola, and for 1 upon b, if we draw graph between 1 by b, that will be a straight line. In next question we need to find density. So density is mass by volume. Substituting the values, this comes out to be the density. We have taken all the units in the SI system, so it should be well understood that all the physical quantities here are in the SI system. Then we need to find volumetric stress, which is equal to pressure. So pressure we know that is equal to P naught plus rho GH. So it will be 51 into 10 is to power 5. Then we have strain. So bulk modulus is equal to this. Using the concept, we have strain as this. Then we have density as mass by volume. So delta D by D is minus of delta V by V over here. So from here we can calculate that delta D by D will be delta Y by V, which is equal to the volumetric strain as given by this expression. Then we have to find percentage strain, so multiply this thing by 100, so you will get percentage strain. Then we need to find fractional change, it's same as delta V by V. Then we need to find density, it can be easily calculated. It can be calculated dimensions of compressibility, this is 1 by bulk modulus, so reversing the dimensions of bulk modulus gives you the dimension of compressibility. Let's move on to the next question. Next is a concept of the stress strain curve of a body and the different things in that. So let's take an example. Suppose we take a rod of certain length L and applies a certain force on it. So certainly there will be stress and there will be strain. So if we analyze experimentally the variation of stress and strain, this analysis can be represented by this graph. This is the experimental demonstration of a stress strain curve of a certain material. So we can analyze the things in terms of certain points. This is OA, BC, D and E. So you can see that in the region OA, stress is proportional to strain. So this is called the proportionality limit. In this limit, Hooke's law is valid. Then you see there is a curve in the region A to B. That means the graph is not a straight line. So Hooke's law will not be directly applicable to this part. However, till there is a point B, till which elasticity remains valid and there is no permanent deformation. That means if you just remove the stress, then the material will undergo no permanent deformation, it will return back to its original shape. However, if you go beyond B, let's say you go to point C, then on releasing the body from that C, it will undergo certain permanent deformation up to a certain limit D, where the stress is maximum, which is called the ultimate stress. And if you expand beyond that, then even with reduced stress, you can see that strain will be more. And finally, at a certain point, the material will break, which is called the fracture or the breaking point. Let's say the difference between D and E is X. So this is used for making material as brittle or ductile. So let's analyze things. So the point OA refers to the proportional limit in which Hooke's law is valid. Then in AB there is a non-linear relation. Then BD is permanent deformation, D is stress increases, stress decreases, stress increases. And for X, if X is large, that material is ductile or metallic. And if it is small, the material is brittle or it corresponds to the non-metallic behavior also. Then there is a question on the basis of that graph is given, and on the basis of graph we need to calculate certain things. The first is the proportional limit. So we know that the straight line corresponding to the proportional limit. So here it is 2 into 10 is to power 10. Then we have elastic limit. So we know that this point corresponds to the elastic limit, which is 3 into 10 is to power 10. Then we have Young's modulus. So Young's modulus can be found by this reason. So this is stress by strain. So here stress is 2 into 10 is to power 10, and strain is 5%, that means 5 by 100. So 5 into 10 is to power minus 2. So this is 4 into 0.4 into 10 is to power 12, or 4 into 10 is to power 11. The third one you can calculate over here. Next is ultimate stress. So you can see the ultimate stress is 5 into 10 is to power 10. Then we have a stress at fracture point. So it corresponds to the fracture point, and it is 4 into 10 is to power 10. Then we have a strain at fracture point. So strain is corresponded by 20%, which is 0.2. Next is energy density at fracture point. So energy density is half into stress into strain. You can calculate it out. Then energy stored. So you need to multiply that by volume. Volume is given over here. So you can find energy stored at fracture point. Then we need to find dimensional formula of energy density. It is m1 L minus 1 T minus 2. So in this way you can solve your question like this. Now let's start with another question. There is a road and two forces X on it. Then we need to find net force on the road, then acceleration of the wire, tension at a certain point, longitudinal stress, longitudinal strain, and a change in length of the wire. So firstly, net force is because forces are opposite, so net force will be F. Then acceleration is net force by mass. We can calculate acceleration. Then we need to find tension. So for finding tension, we need to make the free body diagram of this. And after final calculations, we get tension as this much. Then finally, after that, we need to find stress at that point. So stress is force by area, so that will be stress. Then we need to find the strain. Strain is formed to be this much. Then consider a point at a distance x and a thickness of dx. So for this elemental wire of length dx, let us calculate the change in length. Delta L is this. So delta L comes out to be f dx upon a y. So if we calculate the elemental change in length, so that elemental change in length is given by this much. Substituting tension, we get this much. Then integrating the expression, finally we get, after all the calculations, delta L comes out to be 3FL by twice of AY. So now to escape from integration, we can use a simple trick. We know that delta L is F equivalent L into AY. So you just take F equivalent as F1 plus F2 by 2. So just use this and you get the same result, just to escape the integration, but it is how it works. Next is a question based on applications of elasticity. So the first application is I-shaped girders. You must have seen in railway track I-shaped girders are used. So they just increases the area. So because of increase in area, stress decreases. Then we need to find a maximum height of a mountain. So suppose there is a mountain of h height, we can assume that to be considered to be approximately a cylinder of height h. We just calculate stress at the base. So for safety, that stress should be less than the breaking stress. And using that, we get the highest height as 10 kilometer, which is practically true, as the highest mountain in the world is perhaps Mount Everest with a height of 8848 meters, which is obviously less than 10 kilometer. Then we have the concept of buckling of beam. So buckling of beam is concerned with when a beam is put over a structure, then with due time, due to gravity, it gets bent. So if it is a straight like this, then after some time it will get bent like this. So if the separation between the centers is del, so that is called buckling. And on the basis of experiments, it has been found that buckling is equal to WL cube by 4YBD cube, where W is the weight, L is the length, Y is Young's modulus, B is the breadth, D is the depth. So these are different parameters concerned with that. So in this way you can find the possible graphs and all the possibilities related to this. So this was related to elasticity. I hope these video lectures will prove to be a boon to you. I have omitted all the unnecessary facts, unnecessary derivations, and just included those things which is of use to the exam, so that you can prepare in a time oriented manner, because nowadays overthinking is a great concern. So the first thing is you just study optimized content so that you are able to retain and achieve optimal results in life. Thank you and have a nice day.